Hello everyone. I hope I'm audible to everybody. And today I'm just going to talk about how you can use the new upcoming tools in energy performance, and you can utilize those tools in order to design a sustainable or like energy efficient built form. So my expertise are in architecture. I'm not aware of whoever is attending today's session are all architects or from different disciplines. So I have kept today's talk very basic. So I'm just going to introduce you to the tools available, and I will be talking about what kind of results you can generate out of these tools, and then how you can integrate the results within the design process in order to develop a perfect design where you have energy performance also going hand in hand with the optimized architectural design. So I'll begin with introducing myself. So I already Team Shunya has introduced me, but I'll take opportunity just to give you brief about what I work on and what am I doing currently. So I did my bachelor's from Mumbai University. After that, I worked with Team Shunya as an architect, and I was part of the team who participated in Solar Decathlon China in 2018. And afterwards, I worked with a leading firm called Opolis Architects, where I was project architect for a large healthcare project. And after that, I decided to pursue my master's in parametric design and architecture in Barcelona, in Spain. So with this diverse experience, I will be taking you through like certain examples that I think are important for you to understand how to apply these different tools within the existing buildings, and certain like conceptual designs I'll show you where you can see how these results are generated, how we can modify certain things and achieve different results in order to optimize the performance of the building. So okay, so I have been talking about like tools, like there are different computational or parametric tools that are available, which we can use for architectural design and energy performance design. So what are those tools exactly? All the architects might know nowadays we use Rhino, Grasshopper, and Revit and Dynamo as like basic computational tools to design any architectural building. So what I think is there are now plugins available which are like Honeybee and Ladybug, and like Revit Insight, which are the energy analysis tools. So as we are already developing our designs within these 3D dimensional tools that are there, why can't we already integrate the energy performance also while designing the basic conceptual form of the building? So my work lies within this. So I work with Rhino, Grasshopper, and I use Ladybug and Honeybee tools in order to already integrate the energy performance, and like when I start designing any building. And for uh, for both like Revit Insight or Honeybee Ladybug, it uses the basic data source, which is Energy Plus and Open Studio, which is like an open database where you can take all the weather files and all the data necessary for doing any energy performance. So going ahead, as I said, like mainly I know there is Revit and Dynamo also available, but my work lies within Rhino, Grasshopper, and Honeybee Ladybug. So during today's session, I'm going to take you through series of examples where I will show you what kind of radiation, daylight, heating, cooling analysis you can run on any built form that you are working on, and how you can take results, like actually what all the results you can generate out of these plugins that are available, and what different design parameters are involved in during design process, and how these parameters can affect certain results by modifying these parameters. um, so for that, these are the 4 case studies that we'll be seeing today. So coming to the first case study. So it's a building designed by architect Toyo Ito. Particularly, so this is part of actually my master's work. So particularly we selected this building because of its free form. Because nowadays in architecture, we are trying to achieve like quite free form designs than very restricted, hardcore like the orthogonal designs. So this is a great example where it has both characters. So particularly particularly this building we had selected due to its roof typology, that you can see it has like these basic bumps and where they had introduced skylights. So we decided to run radiation analysis on this and see what kind of results we can generate, how we can take those results further and develop something which will be useful for in terms of like sustainability, or in terms of installing solar panels, what all different methods we use. So I'm going to take you very quickly, very briefly through this. So whenever you begin with any project in rhino, grasshopper and honeybee, ladybug, you need to have a very basic massing model. And most important is, as like ladybug is a open source, so you get the location file. So first you need to identify where your building is located. After the massing is done, find the correct location source file, which is from ladybug online resource, and then you can begin your analysis. So this is just a screenshot I have put up for your understanding, like these are the components from ladybug. And then once you have these things in place, you can start running your radiation analysis. So this is one of the first example where you can see this is an annual radiation analysis, which you can obtain the final result in kilowatt hour per meter square. And then you can take inferences from this and go ahead with your design process. As you can see in this particular thing with this gradient, how like particular shadows that has been cast are changing the heat gain for the ground surface. Also, you can run analysis based on, so this was annual analysis. You can run it based on like a particular month if you want to design for like only summer or only winter months. So this is a result that you can generate out of honeybee and ladybug for radiation analysis. Also, this result you can generate from same components. This is run for the facades. Here you can see how heat gain is happening for all the facades for entire year. So this is an annual analysis. This is during summer months and this is during winter months. So now the question is what you're going to do with once you have these results, right? So once you have these results, you can, being architects, you can start understanding, like particularly here you can see during winter months this facade is getting like maximum radiation. So what does that mean? That means this facade is exposed to maximum sunlight. So how can you utilize? Do you want to take this much radiation and you want to utilize it for heating up the building, as building is located in Japan, or if the such building is located in a tropical climate, can you reduce that much of heat gain? Because already in tropical climate temperatures are a bit higher. So like that, once you have results, you can start reading and taking inferences from there and start applying during your design process. So this is a basic purpose of getting a first base of analysis in terms of any, like you can run daylight also, you can run radiation analysis also, any kind of analysis you can run. And then next step is like taking inferences and going ahead with your design process. So I'll show you a basic example that we experimented during our masters. Was this is the roofscape of this particular building, where you can see there are these skylight cutouts. So we removed those. We want to work with this base roofscape and we want to see how much radiation, how much heat gain is happening on this surface. So this is the result that we achieved out of it. So what can we do further with this? So we tried to run a secondary level of analysis where we did run a clustering algorithm. So this clustering algorithm, what does it do is like you provide the data. So the solar radiation data, what we got out of this particular analysis, you run it through this clustering algorithm. And here we had asked, give us like a maximum radiation that is like received by surface and cluster it, and give us the minimum radiation received by the surface and cluster it. So that with this particular image, we get to know that how much radiation on this surface, like how much heat gain is happening, how much direct sunlight is falling on the surface, and where it is maximum, where it is minimum. Because as we see, there are these bumps. So those are gonna cause shadows. So if I want to put solar panels like this, I need to know exactly which area is available for me to put up the solar panels. So this is like for solar radiation. Also due to the bumps, I need to run this clustering algorithm to figure out where I have as flat as surface possible in order to put my solar panels which are flat in the nature. So with these two data, we run a final clustering algorithm where we ask, tell us like which is the maximum solar radiation on the surface, and tell us which is the most flat surface available. So here you can clearly see all the blue is the surface where we can have flat surface available and we can have maximum solar radiation. After this, you can decide like, okay, then you can tell your client that we have this much of area available to put up solar panels, and then you can start your further work. So this was example mainly focused on radiation analysis. Now I'll show you a next example. This is part of a thesis research done by two of my friends during our masters. So here, why it is worth mentioning during this particular presentation is, I'll try, like I want to introduce you to uh, different tools that you can use during your initial design phase and that can affect your final product. So let's say you are designing a high-rise tower like this, which is a tower designed by mad architects. So here we are going to see how radiation analysis is going to help us to determine like exactly what orientation of each floor is going to be. And with the help of this particular data that we have, the radiation analysis, orientation of each floor, we can decide like how much cooling heating load this building is having, and then we are going to try and optimize if we can reduce the total heating load that this building has, because it's located in Canada, of course there will be more heating requirement than cooling. So if we optimize this number, we can optimize the total, like we can optimize total heating loads generated by this building. So these are the parameters that we will be working with. So here this research focuses on like actually figuring it out, like which particular typology, like shape of the building can be more beneficial in order to reduce the maximum like heat, like how much heat energy is been, like how much heat load is being utilized within this building. So here you can see these are the numbers, which is like the mass addition of annual heat energy, like total heat energy consumed inside, like to heat up the building. And then out of this inferences was like this oval building and this rotation of oval building performs much better than the square building. So then there was a secondary analysis done.
There's a small glitch. We are just sorting it out. Just give us a few minutes. Till that time, if you have any questions, you could put it in the chat box.
Hello.
Yes, you are audible now.
Yeah, yeah. Sorry, guys. I think the new normal's technical problems. Sorry. Can you just tell me where did I lose my internet connection? So I'll go back to that slide.
Oval and rotation kind of thing.
Okay, sure, sure. Can you make me host again?
Akshita, please make Supriya host.
Yeah, just give me a second.
Okay.
Supriya, you are now
Yes.
host. You can present.
Yes, thank you. So I think I have to repeat from here, right?
Yes, yes.
Yes, ma'am.
Okay. So what I was like talking about here was like how you can use already the radiation analysis, and you can run this rotations on the building and find the correct heat, like find the optimized heating loads that this building is going to generate over the year. And then you can figure out, like then it will be, as architects you can give a correct optimized solution to your clients. That's why like I wanted to show you this example. Then next example is I will take you through how you can input different materials, and you can work with daylight analysis and heating and cooling loads of the building over the year, how much it's going to generate, and how you can optimize it with basic either changes in materials or changes in the glazing ratio. So let's say you work with this material matrix where you already have decided what kind of materials you are going to use. You can do a input into your grasshopper and honey. There is a component for it. You can build your custom material based on the properties that like the provider is going to give you. And with this variable properties, you can try and change the percentage of windows that are there on each facade. So this is a result out of that, where you can see total thermal load, how much total thermal load is going to be there in the building, cooling loads and heating loads. And then you can start experimenting with different uh, proportions of the windows on each facade. And then you can understand, like once you start changing this percentage windows, you can see there is a stark difference within the total thermal load that is there. Uh, so 30% windows, if you do on north and south facade, you can see you can reduce the total thermal load by substantial amount. So, and at the same time, you can keep on checking if you are within the limits for the daylight also. So you are not compromising on your daylight, but you are, by not overdoing your windows, you can like optimize your thermal load. So this is how you can use these tools in order when you're designing your any kind of building. This is a particularly a office building. And so going ahead, so I showed you very basic examples where we are running this different analysis. So I'll show you some work in progress that I'm doing right now based on my prior experience working with Team Shunya and my master's knowledge. I realized, like, why can't we start introducing all these parameters while we are starting the whole design process? Because if you see, usually in design, like being architects, we always stick to form follows function. How about now we start questioning form follows climate? So of course, function is important, user needs are important, but how about we be conscious about how climatically also the building is performing? So for that, I decided to develop a working workflow where you start. So what happens, any like whoever is architect might know, there is a very linear process involved in architectural design. So you start from like conceptual massing, then you do schematic design, then you do design development, etc., etc. So what happens is usually this energy performance parameters are involved only during the design development phase, when HVAC, electrical, other criteria start getting involved. So I think it's important to start with the performance criteria from very beginning. So for this, I decided to design a workflow that any architect can adapt and start working with that particular way. So over here, you can see you start with first the site, you understand what is the context, what is the climate. Then based on the client needs, you make a benchmark design. And at the same time, you design like a at the same time you start designing a parametric model where you can start doing analysis on that, start optimizing it, and then keep on comparing it to the benchmark with cost and materials for both the designs, and you can then give a result which is like a optimized form out of all these criteria. So a quick example is like a small scale house. Let's say first you fulfill the criteria of site, context, how user wants that particular house to be, uh, incorporate like the norms and bylaws, like where is the road located, all of that controls like the basic location of like how orientation of that building is going to be, where should be entrance, etc. Once you control that, then you start building the parametric model. So what do you mean by a parametric model? So here I've tried to give you a quick example where you see how you can give different parameters, like you can control what are the roof heights, overhangs, and then start running analysis and then start deciding like how much overhang is required for this particular building. Because in this GIF you can see, as I'm increasing the overhang, the total heat gain on this western facade is changing. So you can, this way you can optimize heat gain on this particular facade. Like that, you can run this analysis in different multiple ways. You can change the roof structure so that here you can see this constant entire surface is getting X amount of heat, which is like directly exposed to the radiation. Once you start tweaking, let's say this roof is changed in its form, you can see this surface is like taking less heat. So this surface is taking less heat. In order to, you can optimize your design further. And then right now I showed you like in these two things you start working, and then later on you check backwards like how much cost is being affected while doing these changes, and then again you can put it into loop, do the optimization. So instead of being in a very linear process,
Oh, what to do, bro?
so you can
Stupid,
work.
yeah, completely stupid.
Somebody's mic is on. Can
Request
you?
all the participants to please mute themselves.
So like this, you can have a very like very intricate process of work, and then you can have you can design a good architectural design with having in mind like energy efficient parameters also. So thank you. This is it. I hope it was helpful and not so much confusing for people who are not from architectural background. I'm open for any questions to answer.
If there are any questions, please put it on the chat box. Also, while filling the registration forms, we had a few questions. So I request Athira to take up those questions.
Yeah, sure.
So are you going to read it out questions to me, or how are
Yes,
we going to
ma'am.
work around this?
Yeah, ma'am. We have three questions. So the first one was from Aparna Verma. So the question goes on like this: along with making a building sustainable, how can the cost for same be controlled?
Okay, so that's why I was showing you this matrix. So what you can do is like, as I was telling you, like once you are taking decisions of changing this particular parameters within design, you keep on analyzing that with your benchmark cost and with your final cost, which is coming out of your analysis. And then you can have, so what happens is when you are designing anything energy efficient, at that time you might be investing little bit more money, but you have to somehow tell that to your clients that over the period of time, if you are reducing this much of energy consumption, effectively this much of cost is also going to decrease. Right now it might be more in construction, but effectively what happens, so it's not a very question of like at the moment of building what happens. So when the project maintenance part comes into picture, you can justify that along with the project maintenance. So over the period of time, X amount of money can be reduced because we are saving this much of energy. I hope it answers your question.
Okay, Aparna, if you are here, you want to ask anything? Do you have any follow-up questions?
No, it solves my query.
Okay.
Okay, thank you. So next question is from Tanmay Ghosh. What can be industrial application of this calculation?
Industrial application. Okay. So for that, I can say it's a because it's like the all the results that we are generating are out of energy plus database, so you can use it as your reference. But being architects, like I am not a professional energy science engineer, but being architect, I am taking these numbers as like reference material to optimize. Then further I can take it to my HVAC consultants and ask them, but I cannot say hard and core that these numbers are the exact numbers that I'm using. So I don't know what exactly he means like further by industrial application. If you can elaborate, I can discuss it further.
Okay, Tanmay, are you here? I think he's not here. We can move on to
Okay.
next question. This one is from
Yes.
Harsha. I think this is already answered, but I will anyway read it out. How could these
Yes.
methods or techniques be applied in various business to reduce the amount of investment required, particularly on energy sources?
This is almost it's an in between answer to, like I can say, question to both the questions that had been asked earlier.
Right.
So yeah.
Okay. So we have questions in the chat box also.
Yes.
Okay. First one is from Sandeep Kumar. Which software is used for energy analysis in residential buildings?
Currently, when people are working in field, they use there are different softwares that we had used earlier was Design Builder and IES, but I am not aware of those softwares, so that's why I have listed it out here. But I am not so much aware of these two. And there is upcoming, because of the BIM compatibility, people are using Revit and Insight a lot during architectural practice. I don't know through particularly like engineering or HVAC consultants what do they use, but architectural practice wise people use mostly Revit. And now people are getting more inclined towards Grasshopper due to Honeybee and Ladybug plugins that are available. This is more flexible during like during your conceptual process.
Okay. Next question is from Madhuganga. Can you give an insight on NVMet software in respect to building simulation?
Sorry, I am not aware about that software. I will Google about it, but I am also not sure.
Okay. So which are the open source softwares? Swapnil Mane want to know.
Open source, currently we just have this database which is open source, but Rhino, Revit, all the softwares are available for students. But if you want to use it professionally, then it's not open source. You have to pay for it.
Okay. So that's
I think Design Builder is open source software, but I haven't used it much.
Okay.
Yeah.
So any more questions, guys? You can put it in the chat box. There is one more question, ma'am. According to you, what is more efficient way on-site climate research or software simulation?
Okay, it's a very in-depth question, I would say. But So I would answer it a bit differently because I myself don't know the direct comparison between the on-site observation versus simulation. But I can surely say if you are doing it during your initial design stage where you are using the simulations, it can definitely benefit your design process. And then later on you can check it on site, because what happens is there are two terminologies which is called microclimate and macroclimate. So when you're working with that, the database is available for a very large scale. But if you want to see exactly on site what is happening, so you can generate your first base through this simulation. Then you can do the tweaks once you actually take data from your particular site based on like the wind directions are changing, or maybe there is some another like new building is going to come up within like next years, and that is going to cast shadow on your building or going to reflect something. There are multiple like criterias that happen once you go on site and actually take data from there. I hope it answers your question.
Do you have any follow-up question? I guess no. And there is one more question. Can you give some tips for making a building sustainable if we do not have access to such softwares? Example, orientation. Like
Okay.
orientation, like yeah.
Yeah. Okay. So what you can do is initially, let's say you don't have complete access to very high skilled softwares, but at least there are many books available on passive techniques of design. So these all are active techniques. But then if you refer to very basic like cross ventilation or wind tunnels, there are multiple ways, because if you study vernacular architecture very in depth, you can see there are certain inherent energy efficient techniques that are available, which you can use to design your building, and you can optimize the energy performance. So maybe if you are not directly going with the softwares, then first step is like doing your passive techniques, and then you can use very basic on-site observations, like if wind is coming in this direction, can I put my window here? And then you can observe with your basic thumb rule calculations, like window ratio can be this much, which is giving me correct daylight but not letting lot of sun to enter inside and heat up the space, or many things like that. So yeah, I think my suggestion will be like doing research like that. Next.
Okay. Thank you, ma'am. And
Yeah.
any more questions, guys? Participants can ask now.
I think if there are no more questions, we'll end the session for today here. And do not leave the meet, because I'll be putting up a feedback form link which you guys have to fill, for after which the e-certificates will be provided.
Okay, guys. Thank you so much for this opportunity.
Thank you, Architect Supriya. It was really an insightful session, which gave us a basic understanding of what all we should proceed with. Also, participants, I request you all to fill the feedback form in order to receive the e-certificates. If there are any further questions, you could write to us, or you could, if there are any further questions, you could visit our sites, or you could write to us directly. Also, we are having similar sessions tomorrow since morning, the details of which I'll be putting up here. Supriya, there's another question. Would you want to take it?
Yeah, sure.
How to innovate and check new materials in simulation softwares?
Okay. I think one sec. I need to reshare my screen. That's what I was trying to show you on one of. Can you see my screen?
Yes, it's visible.
Okay. So while I was explaining you this, so this is a basic material like palette that we had created while doing the research. So when you're working particularly with honeybee and ladybug, there are this EP construction component available, which works with the layers, like what kind of exact material you are trying to create. And then you can put in data that is provided by the material who produces the material. And then you can do your custom material and then analyze that material further, which is a great tool because you don't have to go strictly with like brick or concrete, but how we have like made this sandwich panel here, you can create your custom materials. One more thing I wanted to mention is like there are plenty of tutorials available, and Rhino gives you like 3 months free trial. So I would suggest all of you who come from architectural background, please go through those tutorials and try and explore these few things that I just explained it to you. And there is a lot of like tutorials available for doing how to do radiation analysis, how to do daylight analysis. You yourself, once you'll start seeing, you will understand like what all different possibilities are also there. So that will be really helpful for all of you to know like what components are available. So please go ahead and do that. Yeah, this is it.
Thank you, Supriya, once again for
Yeah.
spending time and informing us about these basics.
Yes.
With this, we would like to end the session.
Okay.
Again, I repeat, we'll be having similar sessions on different topics, that is